Namaskar friends. So we are going to start our discussion on week 3, that is related to the various design tools that are used for product design and development. Let's have a brief review of what we have already discussed in the previous 2 weeks. In week number 1, we have discussed the basic concepts of product design, in which we have seen the need of product design, we have seen the product life cycle, we have seen the various steps involved in the product design process and the other aspects related to the importance of product design. In week number 2, our focus was primarily on the functional aspects of product design, in which we have seen the concept of value engineering. We have also seen how value engineering can be applied in various diverse fields of engineering as well as in service industry. We have seen the functional analysis approach, we have seen functional analysis and cost evaluation approach, we have seen the fast diagramming approach, and if you remember, in the last lecture we have taken a case study of the functional cost evaluation of a furniture item, that was a home divan. So right now we are prepared enough to understand the concepts that go into the product design. Today we will start our discussion related to the design tools. As you know that if we have to design successfully, we should be aware of the various design tools which are used for the product design process. So now our focus is more from theoretical point of view to the application point of view. In the last class also, lesson number 10, we have seen the application of concepts of value engineering for solving a real life problem, that is solving the cost issue related to the cost of the divan. So we have seen that application based learning is much more relevant and important for short courses like 10 lecture courses or 10-hour courses. So it is important that we apply our concepts to the application point of view, and today also we will try to understand the concept of quality function deployment with the help of an example, in which we will see a comparison of the pizza manufacturing companies or pizza delivery companies and see that how the concept of quality function deployment can be used for improving or for benchmarking or for comparing the quality of two companies. Let us now start our discussion on the quality function deployment. First, we will just have a brief overview of the historical aspects of quality function deployment. The history goes back to the year 1972, when it was first introduced at Mitsubishi's Kobe shipyard in Japan. So this is technique which is maybe now approximately 40 years old, maybe more than 45 years old. It is a method of structuring customer requirements and translating into technical specifications as a basis for a new product development. So this is a technique which will be helpful for the development of a product or for the design of the product. So it is you can see two important terms have come in this sentence. First term is customer requirements. So we will see how we can make use of the customer requirements in our design process, as well as the technical specifications. Here you can see technical specifications. So when we will see the application of quality function deployment, we will see these two things are the most important things: customer requirements and the technical specifications. These two things will help us to make our decisions. So it has been translated into English as quality function deployment, and more commonly it is called as the QFD technique, and in Japanese they call it as Hinshitu Kinotenkai. So this is a Japanese name for this technique of quality function deployment. Now the definition, you can see QFD is a method for structured product planning and development that enables a development team to specify clearly the customer's wants and needs, and then to evaluate each proposed product or service capability systematically in terms of its impact on meeting those needs. So basically we have two things here. We will take input from the customer, that what a customer wants. For example, we can say if we are doing our quality function deployment for a design of an automobile, we will ask the customer that what are his requirements. Maybe he may say that he needs a 4-seater vehicle, what should be the DHP, what should be the efficiency, what should be the safety features in the car or the automobile, or we can say what can be the type of drive, it can be manual drive or a geared drive. So we will take all feedback from the customer and then we will document it properly. We will give equal or maybe relative weightage to the various demands or the needs or the requirements of the customer, and then we will try to map these or try to correlate these with the technical specifications, and then after we have the matrix, we will compare the designed product with the already existing products in the market or already existing automobiles in the market, and benchmark our product that how competitive that product is going to be once it is launched in the market. So basically our focus here is on two important aspects. Aspect number one is the input from the customers, and aspect number two is how to meet those customer demands and requirements technically, or how the technical specifications will be able to match the customer's requirement. So same thing has been highlighted in this definition also. In the product planning and development process, we need to specify clearly the customer's wants and needs, and then finally we have to evaluate each proposed product or service capability systematically in terms of its impact on meeting those needs. So technical content has to be there in order to map these customer needs with the actual product. So let us see now the concept of QFD. Maybe 2 slides we will discuss in order to understand the basic concept of QFD. It has been developed to help translate requirements as seen by the customer into technical specifications that can be used by the designer and production engineers. Now it will relate the two things, the customer requirements with the technical specifications. It is a method of linking customer requirements to technical specifications. It helps to focus on needs of customers by using matrices and charts. Usually we do it with the help of house of quality, and we will try to understand this house of quality in today's discussion. Now QFD concept is a systematic approach for translating customer requirements into appropriate requirements at each stage, right from first stage, all of you know, research and development, to engineering to manufacturing, and manufacturing to distribution and sales. So you can see first stage is research and development. From there we go to engineering specifications of the product. From engineering specifications of the product we go to the manufacturing of the product, and then from manufacturing the product goes to distribution and sales. So QFD is a systematic approach of translating customer requirements into appropriate requirements at each stage, or appropriate specifications at each stage, right from the conceptualization, that is research, to the final sales in the market. Maybe automobile designed at the R&D center of any big automobile organization or company, and finally it is sold in the showrooms and the customer can go and buy the automobile. The complete journey of the product is covered right from the conception till it reaches the customer. Now the phases of QFD. Comprehensive quality function deployment may provide 4 phases. We can see phase number 1 is the product planning, that is also called house of quality. Today we will see how this house will look like, what are the various rooms in this house, and what is the significance of each room of this house, that we will try to understand today. So the first phase of quality function deployment is product planning. It will translate the customer requirements into the product technical requirement to meet them. Product design, translate the technical requirement to key part characteristics or systems. In part characteristics we can say the dimensions, the specifications, the tolerances and other parts. Process planning, identify key process operations necessary to achieve the key part characteristics. Now we have already, you can say, done the house of quality. It is now, for example, for this pointer we can say the technical specifications of each and every part, what is going to fit, what will be the dimension of this thing, what will be the size of the slot, all that is fixed at the product design stage. At third stage, process planning, now we have to see that how we can achieve this design, which process will be used, how we can cut this portion, how the mold has to be designed. So that is process requirements. So identify the key process operations necessary to achieve the key part characteristics. Now this part has got certain characteristics. If you can see, it has got a specific shape. How to generate this shape, how the mold will be designed, all that will be covered in third stage, that is process planning. And in the last, production planning or process control, establish process control plans, maintenance plans, training plans to control the operations. Finally, we will do the quality check of the product that we are producing. But in today's lecture, our major focus is on house of quality. These are the 4 stages of QFD which will help us in a successful product design. Let us see the QFD matrices, because here we will use different types of matrix operations where we will give different weightage to different types of requirements, which will be the voice of customers, and the technical specifications. We will try to relate them using a matrix system and then try to do some decision making based on the data that we generate out of this different matrices. Now let us see what are the different matrices. QFD is a main tool to bridge the customer requirements and the process evaluation. This matrix helps in understanding the customer voice. Usually we call it, many books you will see it will be written as VOC, that is voice of customers. So this matrix helps in understanding the voice of customers and response, as well as transformation of this voice into the technical specification. So we will try to understand with a very simple example. I understand that all of the learners for this course or all of the students who have registered for this course may not be engineers. Therefore, the problems that we are considering are not actually engineering problems, they are more of day-to-day problems. In value engineering also we covered the problem of a divan. I could have very easily taken a case study related to mechanical engineering, but my focus was that everybody should be able to have a basic fundamental understanding of the process of value engineering, and therefore divan was taken as an example. Today also all of us relish pizzas, so we have taken an example of a pizza which is in your day-to-day life. You see pizza and you will be able to relate the concept of quality function deployment with the application of a pizza, because everybody can relate to that product. So the different matrices, as I have already told, customer voice will be correlated to the technical specifications. The cascading of the information is achieved by a series of matrices, which is therefore we club it into the form of a house. So there will be individual matrices, and when clubbed together, maybe there are individual rooms, and when these rooms get connected together, you build a house, and that house is called as the house of quality. We will see what are the individual matrices and how these matrices are interrelated to each other, and how we can make a house, and how decision making or what decision making can be done based on this house. So let us try to understand the individual, you can say, matrices here. QFD is known by the house of quality. I have told you, individual matrices combined together, a house is conceptualized or it is made, and that house is called the house of quality. It is called the house of quality because of its triangular roof structure. We will see in the next slide. The house of quality is a kind of conceptual matrix that provides the means for interfunctional planning and communication. Now maybe a product may have different functions, so here we will do the analysis of interfunctional, that is how one particular function is, you can say, related to the other function, and how the different functions influences each other. So that we will try to understand. Now this is, you can see, a house of quality. All the matrices are shown here. The top, let us start from the top. It is a correlation matrix, then the technical requirements, relationship matrix, competitive technical assessment, operational goals or targets, voice of customers, importance ratings, customer competitive assessment. Now here we can see this straight, if we move horizontally, this is related to the customers only. You have voice of customer, as I have taken an example of an automobile. For an automobile, the customers may have certain requirements, which can be the fuel efficiency, the safety, the comfort, as well as the brake horsepower or the seating capacity, all those, or the weight of the automobile with different relative weightage. So all that will come under the voice of customer, that what the customer actually wants. Then the importance ratings, the weight of an automobile automobile may not be too relevant for various you can say customers, so the weightage will be less. But as we see in different advertisements on the television, we see our people, or maybe in India we have a huge fantasy towards the fuel efficiency. Whenever we buy a car, our focus is what would be the fuel efficiency. So maybe fuel efficiency is one requirement of the customer, and which may get the highest weightage here. So that weightage is also assigned, and there are standard statistical techniques to calculate this importance ratings also. But right now we are not going to go into that detail, that how we will calculate the importance ratings, but we will try to understand the overall house of quality in detail. So we have voice of customer, we can have 4 inputs here. Then we have relative importance of these voice of customers, and then as we have seen in all the previous slides, that we try to establish a relationship or interrelationship between the technical requirements and the voice of customer. Now if suppose one is fuel efficiency, here we will see how technically we can achieve that fuel efficiency, maybe redesigning of the engine or redesigning of a particular fuel injection system. So that will come here as the technical requirement. So you have voice of customer, fuel efficiency, and a technical requirement which will help to achieve that customer requirement. And then we have the relationship matrix, and this relationship matrix, usually we will have 3 ratings for the relationship matrix. Suppose fuel efficiency is directly related to one of the one of the technical requirements, we will say they have a strong relationship. And in other case, one of the voice of customers may not be that related to a particular technical requirement, we will say they have a weak relationship among them. So we have a technical requirement matrix, voice of customers, and this is a correlation matrix between the various technical requirements, because one technical requirement may have a positive influence on the other technical requirement, or one technical requirement may have a negative influence on the other technical requirement. So based on that we will fill this correlation matrix also. So we have understood correlation matrix, technical requirement, voice of customers, importance ratings, and the relationship matrix. So all this will be filled, and then from customers competitive assessment, this is kind of an output that we get based on this analysis. So here we can put 2 or 3 competitive companies and try to relate or benchmark our particular output with the relative companies, that what the other companies are doing, or what are their, you can say, targets, or how they fare on the voice of customer. Maybe we may be better than them in 3 of the options or 3 customer requirements, but we may fare poorly for the 4th customer requirement, or 2, or sometimes it may so happen that we are not competitive on any of the customer requirement with the competitive companies. So this will help us to benchmark our performance with, in context of the needs and requirements of the customer, our company as compared to the competitor's company. And finally this is competitive technical assessment, that which technical requirement has got more, you can say, importance as compared to the other. This is a technical requirement competitive assessment. We will try to understand this with the help of an example, and then we can have the operational goals or target. This is one standard house of quality which is used maybe by most of the companies for assessing their product. Now this is the customer matrix, as we have seen. This one, this straight line, horizontal line, all the rooms here are represented again here. The matrix evaluate the voice and response of customer on a particular product. So you have voice of customer here, importance ratings, this is relationship matrix. In previous slide you can see this is relationship matrix, and then you have the, sometimes you can also add complaints here, and then the customer competitive assessment, that how the customer rates the competitor's product as compared to your product. So this is a horizontal base for the house of quality or the horizontal rooms. And then next class this we can see what we have to fill in. This already I have explained. Just quickly we can read the various details of various rooms. You can see voice of the customer, it is an input to quality function deployment. This implies actual needs and wants of the customer, and it is referred as the heart of the matrix, as further evaluation depends on this matrix, because we are going to design a product based on what the customer actually wants. So this is the most important part of our house of quality. Importance ratings, it shows the importance levels from customer point of view. Complaints, it represents the dissatisfaction of the customer. Customer competitive evaluation, it refers to the fact that how a customer rates the product of the company in relation to its competitors. So whatever product we are designing, this will help us to compare our performance as compared to the competition or the competitors or the performance of the competitors. This is the vertical. Already we have seen you have a correlation matrix which will correlate the various technical requirements. Suppose we have 5 technical requirements here, so this will correlate all the 5, that which one has a positive influence on the other one or which one has a negative influence on the other one. Then the relationship matrix, already this is part of the horizontal rooms also. This is related to your voice of customers and the importance ratings, and then the competitive technical assessment and operational goals or targets. So let us now try to see. This is translation of voice into actionable, measurable requirements. So whatever is our voice of customers, that room coming here, this will help us to achieve those targets technically. This is evaluation of relationship between the technical requirements, already I have explained. Evaluation of the strength of relationships between the voices and the technical requirements. How much the company fares against its competitors or for performance against its competitors. Goals or targets set by the company to achieve competitiveness, means this will tell us the target. Here we will get the assessment, and accordingly we can take the decision making. This is the overall, this is the customer section, customer requirements or voice of customers, importance ratings, and then the relationship metrics. This is the overall house of quality. In general, in most of the books you may find 1 or 2 changes here and there, but in general it would look like this only. The major sections will remain same. Correlation matrix will remain same. Technical requirement, voice of customers, importance rating, and customer competitive assessment will be same in almost all the books or literature that you find around on internet. Now this is one example we are going to take, that is house of quality of a pizza. As I have already told, I think the text may be little smaller, but I will read it for you. Now if I ask you maybe what is this matrix, this is the correlation matrix, the technical requirement matrix, relationship matrix, voice of customers, importance ratings, competitors assessment, competitive technical assessment, and operational goals or targets we are not keeping here because we are just understanding the basic house of quality model. So you can see, now you may be wondering what is 6, 5, 1 and 3. We will see what is G, F, P, G. This we will try to understand now. Now you can see that what are the customer requirements. I will read it for you. The customer requirements for any pizza company or from any pizza company is it should be good in taste. Price should be low. Texture should be good, means it should be good looking or the topping texture should be good. It should be low on fats and it should be healthy, maybe healthy ingredients are used. It should be fresh and hot delivery should be ensured, and appetizing appearance means you should feel hungry once you see the pizza. So you can see these are the requirements of the customer. Again I am reading it for you, it may not be clear on the screen. Good taste, low price, good texture, low fats and healthy, fresh and hot delivery, appetizing appearance. So this is, you can say, the voice of customers. This is what the customers want. Now the relative importance rating you can see here, 6, 5, 1, 4, 2, 3. So here you can see good texture is not that important, less rating. Highest rating is for good taste. So maybe a customer may say that 6 is a rating for good taste, which means that it should be tasty texture and other things may not be, is not much bothered, but it should, as it's a food item, it should scintillate our tasting buds or taste buds. So we say it should be good in taste, therefore the rating for good taste is higher from the customer's point of view. Now how we can achieve this voice of customers technically? Maybe the person who's preparing the pizza in the kitchen, what means this is input for him. And how he can do that? He can do it with the help of pizza color, weight, shape, size, thickness, low fatty eatables, optional eatables, delicious and fresh toppings, density of toppings. So maybe these are the technical things which can help to achieve the voice of customers. And then we have to draw a relationship matrix between the two, that which technical requirement is related to which customer requirement. So which technical requirement can satisfy the customer requirement, so that we will see. So this is a representation, this is a representation of a scale. That scale you can see. So this is a voice of customers, the purple portion is your technical requirements, this is your correlation matrix between the among the various technical requirements, this is your relationship matrix, green color. So the relationship matrix, you have low relationship is given a rating of 1, this is standard. In some books you will find 139 also, but that doesn't make much of a difference. So in this case they have taken it as 1, 3 and 6. So this represent low relationship, solid represents medium relationship, and solid with a dot represents high relationship. So you can see good taste with this technical requirement, weight, shape, size and thickness has got the highest relationship, that is the high relationship. Then the taste is also related to the density of toppings, which has a low relationship. So density of topping and weight, shape, size and thickness are two things which are related to the good taste. This is a specific, you can say, information. In many cases it may be low fatty eatables may also have a representation on the good taste, but in this particular case it is not non-representational. So this way 1, 3 and 6 rating is given, and different ratings are given. For example, appetizing appearance, maybe this has got a medium relationship. With delicious and fresh toppings, appetizing appearance, this has got a medium relationship, you can see here. So this relationship is there. And GP means you can see this is G means good, F means fair, P means poor. So we are comparing our product with the company A and company B. So from taste point of view, the company A has good and company B has got fair. So this is a house of quality which we can generate. Now we can do the calculations also, and you may be wondering that how these numbers 3, 45, 30, 11 have come. Now let us try to understand this. This is calculated in this manner. The pizza color 3 into 1. Here let us go to pizza color. This is pizza color. Only one relationship established here. This solid means medium relationship 3 and the rating is 1. So 3 into 1, this comes out to 1. And then the second weight, shape, size and thickness of the pizza, it has got here 6 into 6, 36, plus this has got a medium 3 into rating is 3 into 3 is 9. So 36 plus 9 is 45. Similarly, we can do the calculation and for the relationship matrix and establish this importance ratings. Now this can also help us in our decision making, that when we have to make a tasty pizza, we can say successful pizza. Successful pizza means it is successful from the point of view of business. We know that where we should focus our efforts. 3 is for pizza color. So color has the least, you can say, requirement from the customer's point of view, but you can say weight, shape, size is most important. Second most important is the low fatty eatable. So these days people are getting more and more conscious about their health, so may not like to take a pizza which has got fatty eatables. So if we are low in fat, and we can sell that idea that the pizza is made up of you can say eatables or materials or ingredients which are low on the fat content, the various customers may get interested to buy our pizza. So here the relative importance of the technical requirements has been established, and we can work on these two parts in order to satisfy the customer requirements, and we can benchmark our product with the products of the other companies also, and see that where we stand and may become successful after analyzing the results in a systematic and logical manner. So this is one tool which help us to convert the customer requirements into the technical requirements, and then analyzing the technical requirements among each the different technical requirements among each of them or among each other. So one thing that I forgot to mention is the correlation matrix. In correlation matrix we do the interfunctional analysis. So we go pizza color, you can say going this way, and this is optional eatables that is going this way, so they have a relationship. If you get optional eatables, they have an influence on the pizza color. Similarly, density of toppings has a you can say influence or maybe relationship with delicious and fresh toppings. So this way we can see that which of the technical requirements are you can say related to each other positively. Here also we can have positive and negative. We have not explained it here because the pizza is a simpler product, so all technical requirements may not be competing or may not be affecting positively or negatively. Otherwise we can have here also positive and negative ratings and see that which technical requirement will have a positive influence on the other technical requirement, or the otherwise it has a negative influence on the other technical requirement. So I think now I have tried to explain the role of each and every room of this house of quality, and this is an important you can say skill if you have as an engineer or a manager. You can try to relate the customer requirements with the technical you can say requirements that can be met using your engineering skills or the engineering knowledge. So with this we come to the end of our session or lecture number 11 on product design and development course, and today our focus was on house of quality. In our next session we will discuss the basic concepts of computer aided design. Thank you.